Hello everyone. So today I'm gonna explain virtual machine and container, how it works, what is the difference. I will make it very simple with examples. By the end, you will clearly understand how we moved from the whole way of running the application to VMs and then to the containers. Okay, let's start from the beginning. How the application was first deployed. Okay, before virtualization, the rule was very simple: one application is equal to one physical server. So if the company were running three applications like website, email, and databases, okay, so they need three separate servers. Okay, the problem, most of the servers were only used. Imagine buying a big refrigerator and just keeping a one water bottle. Okay, that was wasteful, right? That's how it was. Okay, and every time we wanted a new app, we have to buy and set up a new server, meaning more cost, more maintenance, and more space, right? So this is a bare metal architecture. So first we have a hardware server, okay, where we have network, storage, and RAM, operating system, and we don't have an hypervisor in this, and that is the big disadvantage of this. But bare metal wasn't all bad. It gives some benefits. Okay, strong isolation. One app never affected another app. Predictable performance. No resource sharing was there, so the performance was predictable. Better security. If one server crashes, the another or act, the another stays safe, right? Still, the downgrades, which means the disadvantages was too big to the modern world, because the underutilized resources. The utilization was busy only in the productive hours, but still we are paying the charges for 24 bar 7. So it, and also it is hard to scale. Whenever you need a new application, you need plenty of time to set up, and the cost also is high. To resolve this, the virtual machine, the first game changer, came into play. Okay, the virtual machine came because we are moving towards a cloud computing, and the virtual machine played a vital role in it. So this is the architecture diagram of virtual machine. First and foremost, we just need a hardware resources. We add a network, memory, compute, storage over there. On top of that, operating system and hypervisor. So what does this hypervisor do? This hypervisor isolated the irrespective of the operating system. So we can run Unix, Windows, Linux in that virtual machine. The application will run. So it is isolating the components in the hardware. So make sure that each VM is isolated to another one. If one gets failed, another one will be running. But if you see this two architecture, the operating system is not there on this. On top of hardware, the hypervisor is there. Okay, I will explain that the next session, how the hypervisor works and what are the different types of hypervisor is there. Okay, so a VM is like having multiple computers inside a physical machine. Each VM is isolated, independent, and fully functional. Okay, let's go with hypervisor. There are two types of hypervisor. Okay, the hypervisor runs directly on the physical hardware, no operating system in between. It talks to the CPU, RAM, and storage directly. Example: KVM, VMware, Zen projects. Okay, on top of that, virtual machines will run. Most used data, this is used in data centers and cloud platforms. Or think of it as a hypervisor sitting directly on top of hardware and managing virtual machine, which will isolate the CPU, RAM, and storage. Okay, so the second type, the hypervisor, on top of an operating system, it will run. Okay, like Ubuntu, Mac OS, or Windows. Easier to install and use but slower comparatively type 1, because it has to go through the operating system layer first. Okay. We had some guest OS hypervisors like VirtualBox, VMware Workstation. On top of this is operating system will run and the application will run on top of that. So think it as a guest app running inside your normal computer and creating virtual machine. Most usually in our personal laptops or desktops for testing. Okay. So on top the virtual machine, the application will can run neither it can be Twitter, YouTube, or also TikTok, okay, etc. So it is giving an isolation. We are using a same hardware, but different operating system is running. On different operating system, we are running a different types of application. Okay, so the VM has solved many problems, right? It reduced the cost because you didn't need a separate operating system for each app. It improves hardware usage since you run many VMs on the same machine. It is give better isolation because if one VM crashes, another one will be still up and running. Okay, so the virtual machine changed the game, but there was some disadvantages also in place. This is the virtual machine architecture. There is a hardware where the memory network and storage is there. On top of hypervisor was there. On top of hypervisor, we are running different types of operating system. It gives us benefits like isolation, resource efficiency, portability, and security. Uh, but they came with big challenges because each VM has its own operating system, which made the size in big and the boot slow in booting up. It take several minutes to boot up one server. So this was fine for older monolithic application. Okay, but when the business started adopting to microservices and cloud native apps which need more speed, more efficiency, more criticality to uh, up and run a pod, which takes seconds. Okay, that's why we need a solution. So what solved this problem? The container solved this problem. So the next revolution was containerization, but technology didn't stop there. Okay, you have to identify, you have to just keep it in mind like that. So this is the container architecture, where we have hardware. On top of that, the container engine was there. In container engine, this kind of application is running on the container. There was no intermediate in between. That makes this more easy to build it, right? So after VM, we wanted some even faster and lighter. That's why we came into the container. So containers works differently from virtual machine. Okay, instead of giving each application having its full operating system, the containers are the host OS. Okay, host OS, but still each app is independent of and it's isolated. Okay, that's the quite difference of this. So let's go on to the next slide, where we could see the different types of containers. Here we could see bare metal and host VM base, right? So in top of hardware, the container engine will run, and on top of container engine, this applications will run, which means the actual pod. Okay, where we could see the second type of containerization type is host VM base. On top of hardware, we are just having a guest OS like Ubuntu and Mac OS. On top of that, the container engine will be there. On top of this application will run independently. Okay, but what we require to build a container, to build a pod where the application will run. Okay, first and foremost, we need a Docker file. Okay, For creating the container, we just need a manifest file, write a Docker file. This is a file with instruction on how to build the container image with OS to use like Ubuntu, Alpine, what packages need to be installed, and what app we need to run there. Okay, this let's consider it as a Rosa CLI. It's talking to GitHub where the source code is storing, and it is building the image and storing it on ECR, and this keeping the ECR with the help of the ECR image is building the containers. Okay, uh, this is a basic example how it works on the background. Okay, let's identify what are the features and the difference between virtual machines and container. Operating system, each VM has its own OS, but container has the host OS. That's a quite big difference, right? The size heavy in GP, but in container it is lightweighted, so the boot up time was less. Startup time minutes, that's why it is container is seconds. Resource usage high or duplicated voice over reader, but here it's very efficient. Okay, isolation hardware level strong, process level, but it is safe. Okay, best for legacy monolithic apps, but modern need modern solution and need microservices, so we have to go to container. So this is a key difference between this all this. Let's go with virtual machines versus container. We could see what is the difference on this architecture. Here we could see an hypervisor. Here we could see a container engine. So that's why containers are the backbone of the modern DevOps and cloud. So after seeing all these slides and detailed information as of now, so now we can understand the difference between container and virtual machine. So now we can clearly see the difference why VM gave us and what virtual machine has given us. Virtual machine was very good for the monolithic application, but we need lightweight, more fast and perfectly suited for today's microservices world, right? That's why containers have become the backbone of modern world cloud computing. But the technology didn't stop there. Now we are just moving towards the serverless services. Uh, that will take in few more years. Will move from containerization to serverless services. Okay, so thank you so much for watching the video so far, and I will see you in the next video. Bye bye.